Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration, and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your questions answered, and contribute to the community dialogue. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our weekly Passive House Accelerator live webinars. In the meantime, here's this week's Passive House podcast. Hello and welcome back to the Passive House podcast. I'm Matthew Cutlerbush, coming to you from Tamaki Makaurau, Auckland in New Zealand.
And I'm Zach Semke, coming to you from Seattle, Washington.
How you doing, Zach?
I am doing fairly well. I am focused on the power of community to make buildings that help fight climate change and keep us safe from its impacts.
Yeah, we should be open up front. We're going to jump straight into the episode this week and talk about positive stuff.
That's right. That's right.
Is that right?
Mm-hmm.
And we're not going to get into talking about why there's plenty of people talking about that sort of stuff. And I figure people hear because they want to listen to something different. And we've got some good stuff to talk about, which I can also relate back to some of the experiences that I've had over the last couple of weeks, but we'll get into that later. We're talking SIPs this week and prefab panels and how that can be very useful for constructing passive houses. Before we get into that, got some people to thank?
We do indeed, yes. So today our accelerator partner of the week is MP Boston, and MP Boston is the development firm behind the Winthrop Center, the major high-rise passive house project in Boston. So it's really great to have them supporting our work this week and all the programming we're doing. Also, a big thank you to our sponsor of the week, Partel. And we just had Hugh from Partel on the podcast, of course, and also a component spotlight on our live series recently. So you can go to the Passive House Accelerator YouTube channel to access that excellent presentation. Also, we have our stakeholder partner to thank, NYSERDA, the New York State Energy Research and Development Authority. Thank you, too, to our founding sponsors, 475 High Performance Building Supply, Ingui Architecture, Partel, Rockwell North America, and Zola Windows. And thanks to our champion sponsors, Bewizo, Icon Windows and Doors, Intelligent Membranes, and Source 2050.
Awesome. All right, I have a couple of jargon alerts for this episode. So I'll just rattle through those. First of all, brands. We talk about them a little bit. That's the Building Research Association of New Zealand. So it's kind of our government-funded, well, it's sort of funded by the government, but it's a shared resource of scientists and people who do work in the building industry. So they offer services and standards and review things, including the P21 test, which is also referenced in this conversation. P21, it's just a standard for wall bracing evaluation. That does get mentioned. So that's all that is. It's just it's a standard way of stress testing structure, bracing elements in a wall. And that also refers to our NZS 3604. In our local area, if you talk to any builder and say 3604, they'll know exactly what you're talking about. It's essentially the timber frame building standard that a lot of our regular framing is done to. So a regular stick frame, timber frame house. And that's relevant because when we go to a SIP construction, it's not a 3604 because we're not using timber framing. And then finally, there's another organisation which does get a mention, which is Scion. That is another publicly funded agency that is focused on the timber industry. So it's a Crown Research Institute for the forest industry in New Zealand. So just apologies for the local jargon there.
One more localization would be R values, the R values that we're using different units.
Always. Right? You mean the ones that the rest of the world uses?
Yeah, it's possible that the rest of the world uses them, but they seem oddly really small
So
values. Our R
R9
values
is
are bigger than your
yeah.
R values,
Yeah, they are. R9 is actually very, very high. So
right?
you multiply that by around about 5 to get an
Yeah,
idea of what that
yeah.
is in imperial. But yeah, so our standard for roof insulation is now around R.6 metric and around R2 in the walls. So when we talk about levels getting up to R7 and R9, we're sort of 2 or 3 times higher than the New Zealand required standard, so that they're significantly bigger. All right, let's get into it. This is my chat with James Clarke, who is from NZSIPs.
Well, why don't we start off, James, just with your background. Tell us who you are and what your background is.
Yeah, so currently GM of NZSIPs. My background is in construction, previously a site agent in London for a developer in Southeast London, building high-end homes. From leaving London and settling into New Zealand, had a brief stint as a river surfing guide. But as you do. But in 2007, took up a more serious role in construction here, and I was a senior project management on the Reese Hotel, 89 apartments. It was, a big complex, big job. It was sort of over 3 years of my life.
So for those not in New Zealand, not visited that part of the world, that's a beautiful part of the world, but pretty in the middle of nowhere.
Yeah, I mean Queenstown is but it threw up a certain array of challenges, like you say. We it's a stunning part of the world, perched. We're on the lake. The temptation to not work and enjoy is a great one.
Along with all the other tourists who are just enjoying themselves.
Particularly powder day and ski season.
Yeah.
You're lucky to get 50% of your workforce there, that's for sure. And who would blame them? But it was a big transition for me, coming from my build methodology in London to what I was first experiencing in Queenstown. So what unfolded was I bought a home from a brand new built home from a builder in Queenstown that started falling apart on me, and straight away, and mold, what we call crying windows now. It was a shocker. And then my son came along. He had all sorts of respiratory issues, and my background being from how I built, where I came from, it was very easy to decipher what was going on. We were living in a very unhealthy home, which was a brand new build.
Yeah.
So whilst I was in this commercial space, my drive was very much drawn to, this isn't good. This can't be how housing is here, for sure. So once I finished my commercial contract, I sort of went on a bit of a journey to what I was going to do next.
Yeah.
And I knew I had to build a family home that was not to the basic code, to standard. I met a German architect, bumped into a very young Thomas from ProClimber that happened to be walking through the streets of Queenstown, pitching this new wonderful rigid air barrier system. That was about 2010. But through this architect, started exploring better ways that we could build a family home. So did that. Rigid air barrier, thicker insulation, that kind of thing. At the time, looking back, it would have been great to have committed back then to Thomas's product. I just wasn't aware enough of it. Hindsight's a wonderful thing.
Yeah.
But because I was kind of in that space, I started a project management company. And like I said, I met Michael Sly. He showed me a SIP. And from that point on, I built a new family home using SIPs. Got into the whole MVHR space, different glazing, and met Guy, and I just got pulled into this whole journey of actually the real science of building.
Where had Michael seen SIPs? Had he spent time in the US?
Yeah, so Michael is into permaculture. And at the time, he was developing New Zealand's first perfume. Classic Michael.
Right.
So he was over in the US pitching his perfume. And because he's an industrial designer, that's his background, he's a very curious person. His mind's always looking for something innovative or makes sense from a construction point of view. He had half an eye on looking at SIPs, and he was deeply researched in the area and landed on this polyurethane SIP out of North Carolina. So while he was over there, he grabbed a sample, and a mutual friend of ours said, "You've got to meet this guy and see what he's got and see what you think." And he came around. He came around for dinner, and straight away I was like, "That's it. That's what we're going to build with."
And had you seen anything like that from your time in the UK, or?
Yeah, a little bit, but again, Matthew, it wasn't predominant. I mean, the Channel Tunnel opened up a new sort of stream of products coming out of Germany and things like that, but it wasn't. We weren't really adopting it. Still very much brick and block, kingspan in between the cavity.
Sure.
That was our methodology until timber frame is now more of a thing in the UK than it was for me back 20 years ago. Right. It's starting to play its part there now, for sure.
When you had that first project, at that time you're bringing the product in from the States because no one was making it here.
Yep.
What did the council say?
Michael and I approached QLDC straight away with the sample.
That's the Queensland Lakes District Council. So that's the relevant local authority that would have to sign off on using that product for a build.
Yep. So we went to see QLDC. They were amazing in terms of very, very helpful. We sat down with them and they gave us a lot of the parameters, what we would need to do to get it through QLDC. I couldn't speak highly enough of them. Councils get quite a lot of bad press, but I've always had good relationships with them in terms of if you approach them and tell them what you propose rather than sort of, just do and then seek forgiveness or try and.
Right. So you had dialogue with them prior to just being a big building consent and on their desk.
Yeah, and try and force the narrative. No, we took the sample in, and at the time the Glenorchy campground was underway as well, and we got a bit engaged with Paul, who was behind that, and the Living Building Challenge. They looked at our product as well, and said it would meet the criteria. So that really pushed Michael and I on to go for it. So we engaged Scion as well. And then what happened via Climate House, the interest just swelled in building with SIPs. Yeah. So rather than constantly shipping air and having this sort of import model, NZSIP was established in 2016.
And so what was the idea there to make it under license, or did you come up with completely your own system?
We took the best of all different things from all different sorts of materials that we'd seen and used. But, SIPs in the US has been around for decades. That they've been doing it for a very long time. So there's a myriad of companies over there, and we just researched what do we like, what don't we like, from what material makeup are we going to use and why. It was really critical. And through there, we stitched it all together, designed our presses. At the time, we had someone on board with us that very strong background in science out of Sydney that did all of the work around formulas and what polyurethane should use, blowing agents, impacts, all that sort of stuff. Matthew.
Right. Yeah.
Way above my capacity, that was for sure. I can put SIPs together, but blending was a whole different new ball game for me.
Right.
So that early days of building with it led to establishing NZSIP. We put the call out for investment, has some very interesting people in that wanted to come on board. But we made some great decisions on who would be a part of NZSIP. And yeah, the factory was up and running July 2016.
Yeah.
And I think, as far as I know, we might well be New Zealand's longest serving SIP manufacturer, not importer. I think it's changing now. People are now manufacturing here, which is great to see. So it all really went from there, and then it sort of just grew and grew.
I want to come back to the core materials and the foam that you went with. Why did you choose that?
Again, that was a round table thing. We'd had this sort of criteria around what I wanted personally for my own family and what I was happy for my own family to be living in a house with.
Yeah.
And Michael and I had long discussions over why polyurethane, and we just felt, due to it, first and foremost, it has great structural integrity,
right?
High R values. It's inert, and it basically, moisture, it doesn't penetrate. It's very dense. So we kind of had these tables going on against the three key ones in the world. We were very close to PIR. It was neck and neck in choosing PIR, but we weighed up everything, all the pros and cons, and said, yeah, we are going to run with polyurethane. And that's really how we made our decision. We just researched globally, and it was just a long pathway of due diligence, to be perfectly honest with you, Matthew.
Yeah.
And then ultimately, it's the question: what would you be happy with your family living in a house made of? And that's where I landed.
You mentioned living building challenge. That's pretty stringent, and it is one of the concerns that I still hear about things like foams. And I know that there'd be a whole nother episode to go into like all the different types of foams.
Yep.
Do you get are people concerned still about polyurethane and about the chemical makeup of that, or how healthy it is or isn't, and how do you respond to that?
You just got to keep it to the facts as well. I think we're all like, my instant response is, well, I'm a father. I have a son, and you want to leave the world in a better place than what you came into it.
Mm-hmm.
And I certainly wouldn't want to be exposing my son to anything that I felt was harmful towards him, in his environment. Personally, I saw the change in his health living in a home built with our product.
Right.
So first and foremost, that's my key answer to anyone asking me, why are you using this certain type of material? The other part of that question is, there's many different types actually of formulas out there on the market. And strangely enough, polyurethane, and a lot of us are oblivious to it, is everywhere in our lives, everywhere.
Mm.
We sleep on it. It's in our cars. It's in our medical equipment. It wraps around our feet. It's literally everywhere. Once you go down that rabbit hole of where polyurethane, it plays a huge part in our day-to-day lives. And even for me, that was a new bit of learning. I didn't realize the makeup of mattresses, right? So I think there are different formulas behind polyurethane, and I'm not saying every polyurethane formula is clean green. Certainly not. No.
Yeah.
But what I do know about what we do is, we don't damage the ozone. We inject in our factory. As soon as on injecting, our product is inert. The world of polyurethane globally, there are some big research budgets out there to try and get it as green and clean as we possibly can, given what I was just saying to you, to the extent that polyurethane is in our lives. All of us that use it understand the obligation we have. Global warming, things like that, Matthew, that we all have concerns about. So I'm certainly not in the business of manufacturing harmful products, that's for sure. But the polyurethane question, fossil fuels, those kind of things, that will never go away.
Yeah.
What we can only do is manage it carefully and do things like our environmental product declaration to say, hey, look, we are completely transparent. This is what our product is. This is the impact that we have day to day.
Yeah.
And
so you've got an EPD.
Yes. Yep. We've held an EPD for nearly 2 years now.
Right.
It was a year and a half of our ops manager's life, Saffron.
It's a big investment.
It was a big investment, but that was our commitment. Like I say, we want to be completely transparent, and that EPD we had to factor even every screw where it comes from, every nail that goes. You would understand it. Yeah, huge body of work, but that's our commitment. We're constantly trying to strive forward to improve our product, and we feel like we're doing that. And our next step really is we're trying to have every component of it based in New Zealand.
Right.
We're getting there, Strandboard byproduct, Nelson Pine, and we're just in talks over our blends being produced here in New Zealand. So
I want to talk about the prefabrication element, because obviously that it's not just the material and the structure changes from standard framing, but the idea that you a lot of your house turns up on site as a paint by numbers jigsaw puzzle. Is that? I mean, that's quite a shift in mentality of the designer. How's your relationship with architects and who designs your houses?
Oh, yeah, the first 2 years was a massive challenge for all of us involved.
Right.
And like you say, I mean, it was interpreting a whole new system.
Yeah.
So I call it the system, the building, the code, and the way we know how to build it. It's when you start throwing different systems into the mix, it's learning the parameters around that system, the constraints.
Mm-hmm.
Every system has a constraint, and that needs to be articulated really clearly. And the early couple of years, I was involved in a lot of developing the technical side of it, and very quickly having a close relationship with brands and Scion.
Yeah.
To say, hey, look, this is going to go mainstream. This isn't just sort of a one or two off builds. We need to develop this literature, quick, and for architects and engineers to be able to understand it, what it is they're actually designing with. We were fortunate in the likes of Guy Shaw of Energy Architecture, having Guy at the forefront, understanding it quickly and designing with it was a huge plus, because I could watch closely his process, and we had a very strong working relationship, so we could iron out quite a few things in design. The key one, Matthew, is the engineering. SIPs really is all about engineering, and that's where I'm saying, coming back to understanding the constraints of that system.
Right.
So that's where Scion played a really big part. Even setting up the P21 test with them was different to how they would do a timber frame P21 test. They'd all stand there at me, look at me in the lab going, well, there's no timber studs. So, and we put it on the rack, and the test was a very different looking test. And then deflection, actual loading, all those sort of things, spans, you very quickly find out that because we don't recognize international code, you can't convert that data. You have to start again, blank canvas.
Right.
So Scion were amazing. Very fortunate that Doug Gaunt there was intrigued, and I spent quite a bit of time back and forth up there testing with them in their lab. And I think if it wasn't for those kind of personalities that could see the potential of these types of products, it may have stalled before it really got started, to be perfectly honest. So very grateful.
Are there constraints that the system has with respect to things like the length of the wall or the height of the wall, or what are some of the physical constraints of using?
Yeah, so there's standard heights. Our walls standard are up to 3 meters high.
Mm-hmm.
As soon as you start going higher, you're in the specific engineered design realm, SED, where brands are praised up to 10 meters high before you really get into the complications of some of the SED that's got to be done.
Right.
So yeah, there are constraints, Matthew, for sure. You wouldn't do a high-rise building with it, you know.
Is that self-supporting up to 10 meters?
Up to 10 meters, yeah, you would have likely wind posts within the panel for deflection.
Right.
The
Yeah.
load on the panel, our panels, is quite incredible. We had when we had our fire testing done up in Auckland by Fire Lab, we had 30 ton applied
Yeah.
on top while they set it on fire.
Wow.
So yeah, the actual load on it is a lot stronger than standard timber framing.
Right.
Where it gets tricky is the actual deflection of the
Mm.
panel. So what we find on the high gable ends that we're doing one project at the moment that's 8 meter high gable end.
Right.
So the panel on its own is not really going to cut it. You're going to need to reinforce it. But the great thing about what we do is because we foam inject in Cromwell, we're all about collaboration as well. So we're working with ProLam on integrating their new portal system within our panels.
Oh, okay. Yeah.
And like I say, being able to integrate foam in timbers as well, we can be a little bit organic.
Yeah.
In terms of what we're building, and now we've got capacity to foam inject panels up to 6 meters long. So we're ever evolving. It's really important, I think, to be able to collaborate and recognize that the timber world for us also plays an important part in what we do.
Yeah.
We're not.
Yeah. You still have framing and stuff inside.
Exactly.
Yeah.
You still need to collaborate. And
you do. We've been talking about walls, but you do floor cassettes and or roof sections as well.
Yes, we do. We do. Floors are really very driven 3604.
Yeah.
The difference being is we foam inject inbuilt joists, strand board, top and bottom, and like say in cassette form. We were manufacturing them up to sort of 1200 by 3.6, but now we can go 1200 up to 6 meters. Again,
and what sort of thickness? What R value can you get up to for your floor and for your roof?
So a 165 floor is R7 out of the packet. So first at manufacturing, and then a 215 is R9.1.
Wow.
Yeah. Now,
so the floor, I mean, that's more than double what most floor. Yeah, it's 3 times the R value of most concrete floor slabs.
It is. And our floors, we've always been doing them, and we didn't really first couple of years we didn't get too many people take up on them, to be honest.
Yeah.
With you, Matt. I think there was always some sort of stigma around putting houses on piles.
I know.
and I'll be dead honest, I was one of those people. But my house is now one of our smart 70s, and I love it.
Right.
But I have to, don't I? The floors, we're starting to see a lot of uptake on the floor about the last 2.5 years. More and more floors are being used. I think that's down to a real shift in what's happening in sort of and I hate to say it, and it shows my age, a younger generation of thinking.
Right.
Our client base is definitely changing. Definitely changing.
Well, I mean, it makes a lot of sense for being able to have a more complete insulation layer all the way around. It's much easier to have a good connection from floor to wall with minimal thermal breaks if you do the continuous system rather than trying to attach it to a bottom plate on a concrete slab. And then you're sort of focusing potential condensation, moisture issues.
Yep.
And then, of course, you got all the air tightness benefits, which I guess all of that leads to you being quite a good solution for anyone looking at Passive House.
We're a fabulous solution. Yeah, I don't know whether I think still the record for air tightness is with our system. I think.
Right.
I know we were 1 and 2 at one point. But, with Guy, we've done a few passive houses. I think Jonathan Holmes was a great one with our system, and air tightness is simply achieved using our system.
Yeah,
I think you get there very quickly. The Camlock system plays a big part in that as well.
Okay, and you tape as well.
Tape as well. Yeah.
Right.
Yeah, we do. So, but the cam locks instead of timber splines, that plays two roles. It's not just about speed of install, but it's about pulling one panel to the next and having a real tight connection.
Yeah.
And also it gives us that pure PUR running a wall, no thermal bridging. It's consistent polyurethane right the way through.
Right.
So
yeah.
It's interesting for your calculations around that part as well.
Yeah.
Yeah. But I think people like yourselves, Passive House Institute, the likes of Guy, modern day platforms and LinkedIn are really good places that people are getting educated on.
Yep.
And they're actually now understanding there are better ways.
Yeah.
And we're seeing that.
Yeah.
People are now twigging to, well, actually, I want more than just a code built house. I actually, comfort levels and things like that are really important to a lot of our clients. And the demographic has changed. We deal with a lot of young families, a lot of clients in their 20s. They're not spec building. They're actually putting roots down, and they know exactly what they want for their family and future.
Yeah.
Very refreshing to see.
Yeah. Now, you mentioned a specific typology there. Is that something where you and Guy have worked together to produce some standard plans?
Correct. Yeah. So Smart Series, that all came about with, there was a sort of a pattern of designs maybe that kept coming through, or constraints with budgets in design and all those sort of things. And Guy and I did a lot of back and forth of what can we bring to market that simplifies the whole process for everybody, from the end user, the architect, the engineer, and the manufacturer, and for council. How can we simplify this and cut costs back around it, and at the same time provide these warm, healthy, dry homes?
Yeah.
And we kicked some designs around, and then we landed on, Guy with his architectural background, what were the ideal sizes, how much space do you need, how big does it really need to be, and we came up with the Smart Series probably about 4 years ago. But like anything, it takes a while. It takes a while. Build it and they will come.
Hopefully, because I mean it's a whole new way of thinking of getting a house, because houses traditionally have been very bespoke in New Zealand.
Yes. Yeah. And I think also there's a fear of that small somehow is not acceptable. Compact.
Yep.
There really is a stigma behind that, and it's interesting, but there is now a real strong shift to going, well, actually, let's reduce the size and put our money into the products that are going to provide us the environment that we want.
Yeah.
Versus a huge footprint that's cold, drafty, damp. That's really what the Smart Series is about. It's saying, hey,
can those achieve passive house, the Smart Series?
They can. Yeah.
Wow.
They can. So there's a baseline design, and Andrea, Energy Architecture, is involved in those designs, and they can achieve passive house. There's like the standard offering of the 115 walls, 165 roof, but we often get asked if they can be modeled to 165 or 215 roofs, Matt, that sort of thing. So
right.
Guy and Andrea will do site-specific detailing to the Smart and also the PHPP. Yeah, so we have certain window suppliers that we use, MVHR, that all forms part of the system for the Smart Series. And then really it's sort of choosing, what color do you want inside, and what does your cladding look like? But most of the thinking is done. Most of the idea behind it is there. So flat packing houses.
Nice. Hey, well, thank you very much, James, for your time. Really appreciate it. And also for your work in New Zealand, kind of changing the industry. Where's the best place for people to go to find out more?
So if you want to go onto our website, www.nzsip.co.nz, you'll find us on Facebook, Instagram, LinkedIn. New Zealand structural insulated panels.
Awesome. Thank you. Appreciate it.
That was James Clarke from NZSIPs, and great to catch up with them. I was down in Central Otago just recently, had a great time down in Wanaka and Queenstown, and that made me think of people like James, because there's a lot of activity going down in that part of the world. Not only is it a very beautiful part of the world, it's also one of our coldest climate zones. So there are people who are, I guess, more attuned to wanting to or needing to build better, and that's why. And there's also a bit of creativity down there, a bit of finance that's available. So it might seem strange that it's quite a small place, but it seems to create a lot of this great environment for local innovation and bringing existing ideas to New Zealand, which is basically what's happened here with NZSIPs. We're benefiting from that now. What were your thoughts, Zach?
Well, a number of thoughts. One was, it was so interesting to hear the origin of this company tracing back to respiratory issues that his baby was experiencing.
Yeah.
in that horrible house.
It's an unfortunately common story.
Yeah, and nothing like that kind of experience to motivate you to figure out not only how to get into a healthier home, but then also to motivate to help make that happen for others. And it's cool to see and learn about prefab at work in New Zealand around Passive House. And so that was really fun, and also I appreciated his openness and transparency about and the work on the EPD, and the acknowledgement that it's plastic, so it's this is coming from fossil fuels, and that's the way it is. But he's working to minimize the impact. I think that some designers are all about all natural materials. That's cool. Others are looking for flexible solutions to create the high performance building, the best high performance building they can do.
And it has to be flexible, because there are so many competing criteria and parameters, including what's available in the market right now. How much does it cost? What's practical? What's going to be acceptable by council and be able to be signed off? And currently, these tick all the boxes for that.
Yeah.
As people do, and I think it is really great. They have done an environmental product declaration. You can go to their technical resources page. They're very transparent about their environmental credentials. And an EPD, there's nothing like an EPD to shine the light on just what the impacts are, not just from a carbon point of view, but EPDs are pretty extensive in terms of the ecological impact on water sources, the amount of other resources that go into that, and the chemicals and materials. It's an interesting point about the petrochemicals. In some ways, I would rather us preserve the easily accessible petrochemicals for uses like this, rather than burning them.
Rather than burning them. That's fair enough. Fair enough.
Burning what could be a valuable resource seems like kind of dumb. When and maybe some will see that as sort of a part of a transition. Don't know. And I think that's the underlying thing where I'm at the moment, is that there's no silver bullet, there's no perfect material, but people are looking for solutions, and the ability that we have now to look at both upfront carbon and embodied carbon allows us to do that in a more objective and quantifiable way, so that we can compare different materials, different building methodologies against each other, which we couldn't really do before. It felt like a bit of guesswork. But I think that's really one of the values of doing carbon calculations, is having a consistent metric that allows you to assess somewhat. It's a sort of a quasi metric for overall sustainability.
Yeah, and also, there may be a future where polyurethane does have some natural, not fossil fuel elements. I was doing some quick Googling and Wikipedia research about polyurethane to learn more about it in preparation for this, and it looks like there's some work going in that direction.
And I know that people are looking at alternatives for for that SIP sandwich as well. To say, how can we to change this up a little bit and think about end of life, that sort of thing.
Yeah. Yep. Yeah. No, it's really cool story. Really cool story.
It is, but it's very hard to get a similar level of airtightness, consistency of insulation, reduction of thermal bridging. I think a lot of those are the reasons why people like Guy Shaw, when they do their first SIP house, they find it very hard to go back to a standard timber frame, in the same way that when people do their first passive house, they find it very hard to go back to just a code minimum house, because they see all those benefits along with some of the structural benefits and the ability to do different forms with a flat roof or a pitch roof with the same panel from the same supply. There's some significant benefits there. So awesome. All right. So we got some more we're doing a bit of a series on prefabrication.
That's right. Yeah, there's more coming. I know Ilka's got some interviews on the way.
Yeah, I mean, it's something we have covered in the past, but it's such a good topic to come back to, because it helps deliver what the promise of passive house is, often in a more consistent way, and sometimes in a more affordable way as well. So
yeah.
Definitely.
I'm glad you said that, because this is actually the theme of the month, essentially, for the accelerator. So our live programs are also focused on prefab. So the 101, and last week we did the project of the month, which is a prefabricated accessory dwelling unit in Boston. That is, speaking of affordability, it's a 2-bedroom ADU, so it's a significant building. Compact, but not tiny, for $300,000, which may in some places may sound like a lot, but that's about a half. If I was able to get an ADU in Seattle of that size, it would cost. I mean, if I were to try to have one built, it would cost $600,000 easily.
Wow. Yeah.
So there is this potential now. Finally, like we're getting an example potentially of one where they've dialed in a FIA certified ADU prefab that you get delivered to your site, essentially, for a really good price point.
And James and the team have done the same. We didn't touch on this, but they actually have standard plans, and the big feature that stands out for me is that all of those standard plans have a price on them.
Right.
Which is unheard of. I mean, standard plans are pretty rare. I mean, designers have design books, or group large volume builders have design books, but they all tell me that those designs never get built, because they're used as a starting point, and then they get tweaked, and every house ends up being bespoke. So this is really putting out in the market, hey, you can have one of these. They're pre-designed, they're good to go, and this is how much it will cost. That it seems like that should be obvious and a no-brainer. I know it's not, because real estate is weird and it does strange stuff. It's not a predictable market always. But I think as the unaffordability increases and the need increases, there may be more scope and just out of necessity for people to opt for a off-the-shelf plan at a fixed price. And again, that's one of the great benefits of prefabrication, just in general as a concept. Yeah,
well said.
Awesome. All right, so you mentioned some of the programming there. What else we got going on Accelerator and also in the collective?
Yeah, so following on the theme of prefab, on Wednesday, November 13th, our construction tech edition of Passive House Accelerator Live will be DFMA in Offsite Construction, Current Challenges and Future Ready Solutions, with Alex Giblin of GoLogic. And then Thursday, November 14th, we're joined by Mike Cairns of Innotech Windows and Doors for a component spotlight focused on triple pane windows, a look beyond U-values. And of course, on December 6th, we have our special Reimagine Buildings Biomaterials Conference. We actually recently renamed it. Used to be called the Carbon Storage Conference, and we decided to go slightly less geeky with the title and call it biomaterials. The content is the same. This is the conference that we are producing in collaboration with Chris Magwood of RMI, the Rocky Mountain Institute. So definitely check that out. And if you are a member of the Reimagined Buildings Collective, you get free admission to that conference. Otherwise, the conference is very affordable. It's $49. By the way, the collective is growing like crazy. We're almost at 100 members. Lots of great conversations going on there. Really fun Ask Me Anything sessions going on. So that's been great.
Awesome. Thank you very much, Zach.
Thank you, Matthew.
That's a wrap for this week, I think. I just want to close out by saying stay positive, and there are some really positive things going on there. And something I said to my team this week was that I know lots of awesome leaders, and very few, if any of them, are politicians. So do good stuff, surround yourself with good people, and if you can't find any, just become one and be a good leader.
Hear, hear.
All right, we'll talk again next week.
Thanks, Matthew.